All right, hello everyone and welcome to Professional Previews. My name is Michael Lewis. I am your host and I'll be joined here today with Mr. Sam James, who is a NASA Model Fabrication Specialist. And in just a second, Sam is going to go into his presentation and tell you a little bit about his background and how he got to do what he's doing. All right, take it away, Sam.
Thank you, thank you. It's a pleasure to be here and to be able to present to you guys. Again, my name is Sam James, and I'm a mechanical engineering technician and I'm a fabrication specialist in aerospace composite and models development. I'm from Elizabeth City, North Carolina. I graduated from Northeastern High in 1983, Elizabeth City State in 87 with a BS degree in industrial technology with a minor in electronics. And I also live about 45 minutes from Kitty Hawk, where the Wright brothers took their first flight. And also NASA Langley is about an hour and 20 minutes from Elizabeth City. Outside what I do, model making, there's other, extracurricular activities that's going on. So my hobbies consist of a little modeling, acting, I love cooking, and I love doing arts and crafts in my garage. I love music, and I actually started playing trombone. I learned how to play trombone in the 7th grade. But my modeling and acting opportunity was, I didn't pursue that, but someone approached me about it, and I always kept my options open. And then when I did get into it, I realized it helped me as a person. I got to meet a lot of different people, and maybe more of a people person too also. But I did shows like FBI Files, National Geographic, Interpol Investigates. So basically they're reenactments of real life happenings. And also did some shoots for Busch Gardens in Williamsburg, Virginia. So these are personality traits for engineering technicians. So if you guys ever sit and trying to figure out who you are, what type of things you like to do, in other words, what makes you tick? So these traits can fit, other careers, but it fits a lot of technical careers, such as self-motivation, being a good listener, being creative, because technology basically changes overnight. And you want to adapt to change and use your time wisely. And critical thinking, team working, and you welcome new challenges because, as time goes on, things are going to change. It's not going to be the same as yesterday. So, and problem solving. Problem solving and critical thinker creates inventors. And one key thing too is patience. You got to have patience, which is very crucial too. So here's my journey to NASA. I actually started thinking about what I wanted to do in elementary school. I was sometimes I'll just daydream out the window where I'm in my homeroom class, like, what will I be doing, Although my father was an entrepreneur, my mother was an entrepreneur, my father had his own business as a plaster and drywaller. But I did learn that trade, but I also love math and science. So one day we had a career day in our my homeroom teacher asked us, what kind of career we wanted to pursue. So I love, making paper airplanes, and I think making paper airplanes is underrated because as you're making paper airplanes, and if it doesn't fly the way you want it to fly, you redo it. You open the paper back up and redesign your airplane. So you're becoming an engineer and not even realizing it. So then I got into balsa airplanes. I started making little small boats, parachutes, and even kites. And I love building tree houses. So technology fascinated me. I always try to find a better way of doing things. So, oh yeah, by the way, bicycle shop. So all my friends in the neighborhood had bicycles and all they wanted to modify it. I'll cut the forks off and then put extensions on them and make it like a chopper. So that really fascinated me, and of course I had to get approval from my dad so I could use part of his garage as my bicycle shop. So, so I share this with my guidance counselor in 7th grade that I like math and science and I love building and constructing things. So she said, well, Sam, go into a career of technology. And so that's what I did. She devised a high school curriculum for me where she devised all my higher math and science courses. Oh yeah, also I learned how to play the trombone in 7th grade. So here's my high school courses, you know, my key STEM courses. By the way, that's a shot of me soccer, one of my soccer pictures, my senior year. I also played football and baseball, and it was in the drama club. But one of my favorite STEM courses is Technical Drawing 1 and 2. It's actually called drafting. And then what I experience as I go into classes and talk to different teachers and students about technology, some technical drawing classes or drafting is offered, but in some classes are not offered. And it's dependent on the school you attend, because some teachers go straight into CAD, and then some teachers produce drafting or technical drawing before they go into CAD. Which I think drafting and technical drawing, learning that first is good before you go straight into CAD. But it depends on your instructor. I had to take trigonometry, of course, algebra, geometry, trig, calculus, good old physics and chemistry. And then I had to take the physics labs and the chemistry labs also. So my school activities were really fun. I was in the art club, honor society, and also locally in Elizabeth City, we built floats during our parades, the Christmas parades and Thanksgiving parades. And the photo at the bottom is near the Pasquotank River in Elizabeth City. Our art teacher took us out there so we can do landscape drawings of the river. And I was heavily into art when I was in high school, on top of being STEM, you know, having a STEM background. So at Elizabeth City State, I majored in industrial technology with a minor in electronics. Again, engineering graphics 1 and 2, that's the same as technical drawing 1 and 2. So one thing I found out when I started getting into my major, I found out a lot of other classmates didn't take the same path that I took. They didn't have the STEM background like in high school. And so my technical drawing professor had me to assist some of my classmates to help them learn how to draft. And I love statistics and fluids technology, statics and strength of materials. I see that a lot in what I do at NASA. Manufacturing processes and computer programming, that's 1 and 2. That was an old programming course called Cobalt and Pascal. I don't know if you remember, and Fortran. I don't know if you ever watched Hidden Figures in the movie, and I think her name was Mary Jackson, that had to take Fortran so she could run the computer lab at NASA. But now that's an old form of programming, so they have newer types of programmers now. So my college activities and study groups is what I started in high school. So what I did, basically found a lot of classmates and friends who had the same major that I had, and we stuck together throughout the 4 years. So before we take our final exams, a few days before we take our final exams, we get together in the library and we study. Or some will come to our rooms or where we stayed on campus, and we'll study together. And it works, because some students may know something that you may not know, and then another student and you may know something that your classmate doesn't know. And so I was into drama also in high school and college. And actually, I was voted Mr. Sophomore, and the thing about that, I didn't even put in for it. A friend of mine said, hey, put Sam James as Mr. Sophomore. And so they voted on it, and before I knew it, they said, congratulations, Sam, you became Mr. Sophomore. So that was pretty cool, though. So let me go back. As a junior at Elizabeth City State, it was the fall of 1986. I'll never forget. My electronics professor said, Sam, NASA Langley is hiring technicians. You might want to put in your resume. And I thought about it. I said, wow. NASA, I said, NASA probably won't even think about me, because I was, Elizabeth City State was a small school. I was thinking they probably wouldn't even hire me anyway. And then I told myself, I said, look, they will never know about you if you didn't put your application in. And so I put my application in the fall of '86. I graduated May '87. Do you know NASA called me June '87? Out of the blue, they say, Sam, we have a position for you in aerospace composite models. And I was one of the happiest guys in the world, because it was really awesome to go straight in their apprentice program. I started in 1987, July of 1987. And so one thing about this was a mechanical technology background. So I had a BS degree in industrial technology. So I had to take a few more classes locally at a community college, Thomas Nelson Community College, which is now called the Virginia Peninsula Community College. And those classes were Advanced Composites 1 and 2, CNC Programming 1 and 2. CNC Programming, not sure if you know what that is, that's computerized numerical control. So basically you're using numbers or dimensions of that part. And you're actually programming, that piece using dimensions for your X, Y, Z coordinate system. Fundamentals of flight, and I had to take metallurgy and compound angles. So that put me at mechanical technology. Today, they call it mechanical engineering technology because over the years, technology has increased and gotten better. So they have to implement these courses now in college. So they call it mechanical engineering technology because of additive manufacturing and numerical CNC numerical control and other new technologies. So you'll be up to par when these technical companies hire you. They want you to be, up to par with the new technology. What you see in the picture there, that's me accepting my certificate of completing the apprentice program. It took me 4 years. And down below you see, that's my first project I led coming out of the apprentice program. It's a 2% blended wing body. And you can actually pull this up on, you can Google it or you can pull it up on YouTube. All you have to do is put in NASA blended wing body. You can see this airplane in flight. We have built different scales from 1% to 5% scales. And we basically use fiberglass, graphite materials, and lightweight materials to keep it light. Here's some of the materials that we use in model fabrication. We have honeycomb, and basically we have a company called Hexcel that makes this honeycomb, but it's man-made, but they get the idea from a bee's nest. And they found out the structure of it, man-made, is hard to compress. So we incorporate this into some of our remote piloted vehicles or UAVs to keep the weight down. We use epoxy resin that you see at the top in the middle row, and next to that, to the right, is graphite materials. And right in the middle, in the center, you see a mold of a 1% blended wing body. We have fiberglass in there, which is the shape of the profile of the blended wing body. And that's me down the left-hand corner. We actually doing making some graphite specimens. I'm making some graphite specimens with other technicians. And we try to squeeze all the resin out so it won't be resin rich. Because too much resin, although graphite is light, too much resin will add weight to it. So we'll try to move all the resin out of the graphite. And it's under a vacuum at the same time. It's under a vacuum. So as I was telling you about changing technology, this July will be 36 years I've been at NASA Langley. And I've seen the changes of technology from 87 up to now to 2023. So early on, mold and pattern making, we made all of our patterns and molds by hand. And the process was really long and it was tedious. And to go from making models by hand to CNC machining, which is numerical control I was telling you earlier. So basically you program the machine to cut this out, this mold or pattern out. So let's say a 12% F-18, a Navy aircraft, 12%, making a 12% mold, which is in the first row down at the bottom. It took about 3 months to make the molds for that. But when we programmed it for the CNC machine, it only took 3 days. So what a tremendous amount of time that has saved us. So that's pretty cool. And then you have 3D printing. We started off in the mid-90s using it's called stereolithography. You can Google this also online and see more about it. And it's basically using resin that's as sensitive to ultraviolet rays, which this machine had the laser light had the same rays as the sun. And this ultraviolet light actually cures the resin as it's built in 4/1000ths of an inch sections. And it's in 50 gallons of resin, so the tray is moving up as it's been made. So the neat thing about 3D printing and additive manufacturing, you could start on a Friday, let it run while you go home, and come back on Monday, the job could be completed. So that's pretty neat also, pretty awesome. So we can do a lot of things with 3D printing and additive manufacturing. Good old blended wing body. This model actually was for Boeing. We do a lot of work for Boeing, the airplane industry. Boeing actually makes the full-size airplane, and we build the model size. And the reason why we build model size is because it's less expensive. You don't risk a human life when you test it in the wind tunnel. And the turnaround time is real quick when you have to redesign it, because we test one blended wing 5% scale, which is down in the right-hand corner at the bottom. And it's supposed to carry 850 passengers, and the width of it is the length of a football field. That's how big it's going to be. So when they tested this in our full-scale tunnel, they found out it was going to be really heavy with the luggage, with the people, and with the fuel, and they redesigned it for 450 passengers. So you can see that also. You could Google NASA blended wing body on YouTube or Google, and you can see more information about it. But one of the first things I asked the researcher about this blended wing body when we built it in 1990, I said, when do you expect this to come out? They said 2020, so here we are, 2023. So they ran into some issues with the structure of it. It was really expensive as far as, because they're going to use graphite instead of metal. Graphite will keep the weight down so you have better fuel consumption. And that's the whole idea for any moving vehicle, even automobiles. You try to use more lightweight materials like hard plastics or fiberglass, and most of the automobiles are still built with metal. The frame is still built with metal, but a lot of the outer surfaces is a lot lighter now. This is one of my favorite models of 757 General Transport. You can also find this on YouTube. Just Google NASA GTM model. This model can get up to 200 miles per hour. We use small jet engines, and we use kerosene and an oil mixture for this model. So it's a 5.5% remote control model, and it has small turbine engines. So the idea for this is it's called refuse to crash. So they want to cut back on aircraft fatalities by 95%. And so to do this, they will put this airplane in upset conditions, and then they'll try to recover it. So in other words, if you have a human error, like if it's a pilot make an error on the airplane while he's flying it, or you have a component error, so they want to be able to take the controls from the pilot and fly it remotely themselves without the pilot even touching it at all, and land it remotely. And that research is started in 2001, and it's still ongoing now as I speak. So that's one thing about the research at NASA. It can be continuous. If it's new and innovative, the research could last a really long time until they get a good handle on their research, such as the blended wing body that started in 1990, and here's 2020. It's not out yet, but they're still close. They're looking at maybe 2025, 2025 or 26. And we also do, so NASA Langley is the very first NASA center. It was established in 1917. So we have 10 different NASA centers throughout the country, but NASA Langley was the very first one. So what they're looking at, and by the way, NASA Langley is an aeronautical center. When I say that, they do more aeronautical research than space research. So it's like 60% aeronautical research and 40% of space research. Johnson Space Center and Kennedy Space Center, majority of their research is space. And so what I have here is called an inflatable airlock. And what's so neat about this is they want to replace the hard shells capsules that they use to connect to the space station, and use something like this inflatable airlock. For one thing, it's easy to fold, very lightweight. So when you put it in a space vehicle, when they take off to go up in space, so you don't have to burn more fuel with something really heavy. So this is very lightweight, and it's called soft goods. And so basically they have an internal bladder inside of this fabric here, which is called Vectran, and they actually inflate it when they get up in space. So the early concepts here, I did a 15% and 30% scale early concepts to convey the idea and show the managers that this could work. And I was actually doing this for a NASA researcher. He works in the space program. He did a lot of space research. And so the multiple uses for this could be a crew cabin, space hangar, inflatable freezer, or quick response hospital, or even living quarters for the astronauts while they're in space. So down in the right-hand corner, you can see inflated airlock that's attached to one of the capsules that will be on the space station. So this is pretty unique also. And so they can also use it too to connect the lunar rover where the astronauts are right in while they're either on the moon or Mars, and it's attached to the habitat where they live, so they don't have to put on a spacesuit to go outside. I mean, to go from the lunar rover to the habitat, they can go through this inflatable. I basically call it inflatable hallway. So you could use it for that also. So we get a lot of NASA interns, we get some high school interns, and we get a lot of college interns from all over the country. And so these groups here were in a aerospace program put together by NASA headquarters out of Washington, D.C. So once they get on center, they're given the instructions and they have been told what type of project that they need to fabricate. And so I help them with the structures, you know, getting the right materials and doing the layups to build the structure of these models. And it's pretty cool because you have mechanical engineers, you have electrical engineers, software engineers, and all of them have to come together collectively and do their part to make this happen, to be successful. Now the yellow and black vertical model there in the group for the right, they made a UAV that can pick up a package. So they have 4 doors on this UAV. And basically it's what Amazon and Google were doing too, picking up a package. But the neat thing about theirs is they have 4 doors. I think Amazon just had some type of magnet and then the package was exposed. But in this case, they all have 4 doors that can enclose the package and then put it at your doorstep or drop it at your doorstep. And the group down with the orange model called the Tigress, that was a UAV that they use sensors where they can scan crop to help the farmers. So instead of irrigating all their crops, so they'll find the dry spots in like a crop of corn and then find out where the dry spots are and just irrigate that one spot instead of the whole field. So it saves the farmers time too, time and money. And so down in the left-hand corner, you have a gentleman, he was in the governor school program, high school at Hampton High School in Hampton, Virginia. He was doing a layup with graphite layup for the 1% blended wing body. And the gentleman to the right is an intern from University of West Virginia. He made a 50% scale Mars flyer. Back then, I think NASA Langley was making a proposal for the Mars flyer to use to scan the surface of Mars to find, you know, living organisms or water on the surface of Mars. But it's really cool to work with these students. They come in enlightened and ready to go and ready for any challenge that's put in front of them. And they couldn't do it without STEM background, you know. For the technical world, you know, STEM background is something you definitely need, you know. And then talking to some of the students, they do have little extracurricular activities like myself. You know, I found a couple of students that play guitar, you know, and some play a clarinet, so they were into music. So that's where the arts come in. So, so that's, you know, you could become more well-rounded by incorporating arts into your background. And finishing up here, I'd just like to say the first steps towards success is really realizing who you truly are and not who you want to be. I know there's a lot of athletes, there's a lot of actors and actresses on television who's like, wow, I want to be like her, I want to be like him. But you need to find out who you really are. Look at yourself in the mirror if you have to and say, what do I like? What kind of person am I? You want to find that out early on, you know, while you're still young. And then so that'll give you some idea or give you a gauge of what kind of career you want to pursue also. It could come from caring for a person. You may want to be, in the medical field, as a nurse or something like that. Or, even if you're helping the homeless, you could still use that too as, something like a guidance counselor. The guidance counselor help people too. But, being a people person puts you in an area around a lot of people in people environment.
All right.
But that ends it. And so any questions you guys have, I'm looking forward to what you have to, ask.
So just so everyone is aware, feel free to drop your questions in the chat. I've got several questions that I've been typing up in the meantime. And if you wanted to talk to Sam directly, we'll have some time at the very end of the recording, or after we stop the recording, but we'll get to that in just a second. So just going through some of these things, what would you say, Sam, was that first aha moment of you really realizing this is what I want to do, or trying something else out and realizing, oh wow, this isn't what I want to do?
Well, the aha moments came even before I got to middle school, when I was in elementary school. And so I was at home, again, making paper airplanes, balsa airplanes, and other unique stuff, anything that I could think of that was really neat that, you didn't, other kids weren't doing. And then I found out when my friends in the neighborhood saw what I was doing, they were amazed, like, man, how you do that? Where you get the idea from, completing that or making that type of airplane. Mm-hmm. And so I kept getting a lot of compliments on top of being really good at math, loving math and all. I was like, man, I'd like to be in a technical field. I'd like to be, somewhere where I can really, have an impact in the world. And at the time, I had no idea because I still wasn't exposed to a lot until, again, I got in middle school, and then we had the career day. And then my guidance counselor gave me some direction and helped me out. And that's how I ended up here at NASA, So that was pretty cool.
Yeah, and so kind of leading into that, as you just said, NASA isn't all astronauts. I think that is what people typically think of when they think of NASA. They think people going into space, but right. NASA is so much more than that. So what are some of those other things that are there at NASA?
Yeah, I'm glad you brought that up, Michael, because when I was young then, back in elementary school, and seeing the space shuttle go up, all I thought NASA did was space, even though aeronautics is in the acronym. So mm-hmm. they did, but it didn't really dawn on me because the space, just took over, got a lot of attention. So, so you have biologists, you have electronics, people that do electronics engineering or electronics technicians, and then also. NASA Langley is set up like a small city. I mean, we even have a fire department. We have our own fire department. So if you're interested in becoming a fireman, you could still end up at NASA, who knows, as a fireman. And so we have a fitness center. So we have people into fitness at NASA. So really, so you don't just target an astronaut. If you work at NASA, you have to be an astronaut. No, you don't. But there's a lot of other careers that's involved in NASA. You just have to do a little research and Google searching is right at your fingertips. Finding this out, you can find a lot of this information if you do some searching and find out other careers at NASA Langley, or just NASA period at the other 10 different NASA centers. And we have nutritionists too, nutritionists also.
Yeah, so a little bit of everything.
Yes.
It's essentially a whole functioning society there.
Yes.
So Savita asks, does everyone who gets an internship end up working at NASA? Because you talked about your internship there. And then as a follow-up, would going to space camp help get an internship there at NASA?
Yes, there's a plus for both of those questions. But unfortunately, every intern doesn't get hired. But just because you don't get hired, that doesn't mean that's your end for not getting at NASA. You can always try, you may end up a couple of years later, even if you go with a contractor. So what's happening, we get some people who get hired by contractors that work for NASA. And so you can do that, but at the same time, if you still work for that contractor and then want to someday work for NASA, well, when NASA put out job descriptions or put out new jobs, you can still apply for that as a contractor to become a NASA employee too. So in other words, you know, you can work for another company, another organization, using that as a stair step, you know, as a stepping stone to get to your, you know, final destination. But and the other question was about
Going to space camp.
Space camp. Yeah, space camp is a big plus. Because if you see that, if you putting out a resume to NASA and want to, you know, you want to work at NASA, when they see stuff like that, space camps, so that tells them where your mindset is, where you aspire to be. You know, this is what you're looking at. So they may give you an opportunity to become an intern. And then also keep in touch. You know, like I will say myself, you know, I can give you my email. So I give a lot of students my email. So keep in touch. So if you're in high school now, you're looking at maybe being an intern at NASA when you get in college. You know, you keep in touch with a NASA personnel such as myself, and then I can give you a heads up on, you know, what's been offered or the next internship spots that's coming out. If you don't get at NASA Langley, you could get at another NASA center. You know, one of the other 10 NASA centers too. Yeah. So it's all about context, and that's why I tell students is to get information from everyone you run into, you know, because you never know that someone may send you something and say, hey, you know, here's an opportunity, and grab it.
Yeah, yeah, and I think Savita said that they're in 5th grade, so they got a little bit. Yeah. They got a little bit of ways to go, but your mind is in the right place, and you know, definitely keep those connections, Savita.
Yes, that's a head start, Savita, too.
Yeah, yeah.
The earlier, the better. So it's never too late, you know. I mean, never too early or never too late either way.
Yeah, and then you mentioned working with some interns yourself. So were there ever any interns who didn't always want to work at NASA? You know,
that's amazing because. It's amazing because just every intern that I have that come through NASA, every one of them wants to work at NASA because NASA is like a big family. It's like family oriented, you know. And NASA Langley, where I am, it feels more like a campus, like a college campus, because we have our own cafeterias. Again, we have our own fitness centers. We have intramural sports. We have volleyball. We have flag football, and then we have basketball. And we have our own tournaments within NASA Langley, so it's pretty cool.
Yeah, and then, you know, speaking of some of your extracurriculars, you mentioned that you were nominated and won Mr. Sophomore. So what did that all entail, you know, being Mr. Sophomore?
Yeah, been Mr. Sophomore. I was nominated at Elizabeth City State, and what I found out, there were people who didn't personally know me but heard about me, how, you know, nice of a guy I was, and I was like, man, I was in awe. And that's one thing I can say about character is it's nice to have a 4.0 in your academics, but it's good to have a 4.0 in your character too. And that's how I became Mr. Sophomore, because, you know, people found out what type of person I was, and that, you know, they felt that, hey, this was the opportunity for me, for Sam James, because they just had a lot of good things to say about me, and I really appreciated that. But one thing I do, I just be myself. You know, I don't try to be like others. You know, I have my own personal, you know, attributes and personal things that I like to be well-rounded as a good person. But I respect everybody, you know.
Yeah, and so kind of like you said at the very end of figuring out who you truly are rather than being someone that you're not. You know? So yeah, I think those are very good words to live by. And so I had a question about the inflatable airlocks. So one of the things that we have to worry about in space is like micrometeorites and radiation and all of that stuff, because there isn't this giant atmosphere and magnetic poles everywhere. So the inflatable airlock just kind of looked like, you know, kind of like a plastic greenhouse.
That's a very good question.
What is that made out of, and you know, what are those safety measures that are taken?
I'm glad you brought that up, Michael. That's a very good question, and and that's what the outer fabric that you see on the slide there. It's called Vectran. This material that I was using. So early on, when I was making my concept models, I didn't use the actual material, a Vectran material. I was just using something else until I got a handle and understanding of the concept. So when I did build the full-scale one, which is about 10 feet by 17 feet, I actually used the real material that they would use up in space. And it's called Vectran material. It's really expensive. Even the cords were called, the cords that I had within it is called Vectran material. So it's just as strong as Kevlar. And that's the reason why they use this material, to protect from meteor storms.
Yeah.
Because meteor storms could, you know, flash into it, and then if you don't want any holes in this thing.
Right.
So they have some really super strong material called Vectran to support that, to protect it from meteor storms like that. But that's a very good question.
Okay, yeah. And then a similar question is, so with the models, you mentioned that some of them are made out of like the resin materials, and graphite is something that you use often. Is that the final product? Like, do you end up using graphite with the full-scale model, or is it different material composites, or yeah?
Very good question. Another very good question. So these models that we build, the materials that we actually use will not be used for the real airplane or the real spacecraft. These materials are used for the smaller scale. And then also these materials are used too according to the wind tunnel that they're being tested in. So it still has to be durable material. And so it's built according to, it's fabricated according to what wind tunnel it's been tested in. But the material is actually different for the full scale, when they decide to build the full scale spacecraft or aircraft. It's totally different.
Yeah, and so completely off topic to this, would you ever want to go into outer space if given the chance?
But you know, I thought about the outer space, and then I realized, hey, you know, you have to be 6 feet or shorter. I'm 6'2", so you had to be 6 feet shorter, because the space is, like in the space vehicles and in space, is very confined. So you can't be you can't be too tall. Because you'll take up too much space and be uncomfortable, and then it could harm you as a person. I mean, you know, they want, you know, safety is very important. So they figure, you know, a very confined space, you know, taller person, you know, something may happen. You know,
if we were in that perfect universe where, you know, people like ourselves, being taller than 6 feet, could comfortably go into space, would you want to go?
You know what, I thought about it, you know, and I was like, well, it seemed like it would be really, really cool, but I probably would. I mean, my decision has changed, you know, since 10 years ago. 10 years ago, I flat out said no. But if I was able to go even at 6'2", I think I probably would, you know, become an astronaut.
Yeah.
It's pretty cool.
And so there's another question. How strong does the material that protects the oxygen in space? So I'm guessing the oxygen canisters or whatnot, like how strong is that material? Is it a different type of metal than we're used to on Earth, or?
It's sometimes they use different materials, titanium, but they secure your oxygen tanks are very secure, and then they make sure the fixtures are tight enough where oxygen doesn't escape. But they do all this before it's even up there. They secure everything, even like basically testing the space vehicle before it takes off. They do a safety check. It's what they call safety checks. They do all safety checks before they even go up in space. They make sure everything is secured. And if they find something wrong, then that's how they delay the launch. They say, wait a minute, we can't go now. But the same thing with oxygen tanks, if they want to take that up there, it has to be secured.
Yeah, and so when you were talking about making the models and going from like drawings, you mentioned drafting, and now I know a lot of people use AutoCAD, which is a computer software that is just drafting, computer automated design. What does that process look like of creating something? Do you test it in a virtual space first before you print a scale model and then do a larger model, or, you know, kind of what does that iteration process look like?
Yes, that's a good question also. And from what I understand too, the researchers, they are close to actually doing computer tests to a point where, you know, you might not have to build a model for every test, but the reason why, that's the reason why we build models, because a physical model gives them more accurate data. Now they can do computer tests on a computer of that particular vehicle, and they may get an idea or understanding how this vehicle is supposed to act. But as far as accuracy, accurate data, a physical airplane or model airplane will give them more accurate data, or physical spacecraft will give them more accurate data. But a computer-generated one, and what they do with that, of course, with CAD, you see that's why you see different colors. You don't want to have your CAD drawn with one color, because then you can't see the 3D effect. So
Right.
that's why you have different colors, for different sections of that vehicle.
Yeah. And so what would you say is the best thing about what you do currently?
You know what, the really awesome thing about what I do is really working with the world-renowned researchers, NASA researchers that's known, throughout the world, and does research, with other countries, and, collaborate with other researchers around the world. They a lot of them come right at NASA and at other NASA centers. I've met other researchers from other NASA centers like JPL, Kennedy Space Center, Johnson Space Center. But working with these researchers, and then actually what's so neat to work with these researchers is to get put in on a patent with them. So while I've been at NASA, I've been put in for 2 patents with, by the researcher. And they don't have to do that if they want to, but that's basically showing their appreciation for me working on their projects and bringing it to life, their new innovative ideas, and bringing them to life. So they're so elated that when this thing is getting close to a possibility to become a reality, that's how we're rewarded,
Yeah.
We're rewarded with a patent. So it's pretty awesome. That's a great feeling too, and it gives you more confidence. So coming in as a technician, as an apprentice, it kind of, you kind of question yourself like, man, can I really do this? When I saw all the things that they do, I was like, wow. But the minute I start learning this process, the more confident I got. But I'm the type of person, I love a good challenge. So this was very challenging starting right off as an apprentice.
Yeah.
And so the more I learned and the more I understood about the fabrication process, the more confident I've got.
Yeah.
And so that's really important. And you may feel the same way. When you're on the outside looking in, it's like, man, I don't know if I can do that. But once you get in there internally and understand, get the training and get the right skill set, and then before you know it, you're a mechanical engineer and a fabrication specialist.
Yeah.
So always have confidence. Look, never doubt yourself. Because one thing when someone tell me I can't do something, that only motivates me. So when someone tell you, you can't go here, you can't go to this college, or you can't do this, let it be motivation for you. And so that's what I did also, because I love to prove people wrong.
Yeah. Prove the haters wrong.
Yeah, prove the haters wrong. So.
Yeah.
But you can really do anything you put your mind to, honestly. But just stay focused, because there are some negative people out there. And one thing that helped me in life, too, is coming up as a student, I surround myself around positive people. I surround myself around positive students. And I did that throughout my life, because negative things will eat at you. And you don't want to hear that. But, stay positive and stay focused on your future and what your goals are.
Yeah, and so I was going to ask next, if you can go back in time and tell your younger self anything, what would you say? It sounds like that a similar message would be...
But you know what? It's funny you say that, because when I got hired at NASA, and I hated public speaking, and I was saying this is why I'm here today doing educational outreach, because I hated public speaking. I said never saw myself doing it, but when my supervisor called me in the office to tackle this new organization that they were establishing, basically like STEM, it was the acronym was ADAMS, Adventures in Technology with Option in Math and Science. So they needed employees to go into the classroom to tell students how important math and science is about your career. So I hated public speaking, and I was like, man, I don't know if I want to do that. But I didn't have to do it. It wasn't mandatory, because I don't get paid for it either. But it was a volunteering thing, And I was like, thought about it for 30 seconds. I turned back around, went in my boss's office and say, hey, I'll do it. And the rest is history, and here I am today after over 30-some years.
Yeah.
And so when I tell students, because a lot of students thought I get paid for doing education outreach, and I don't get paid for it at all. I'm just giving back to community, not only in my community, but to the community throughout the country. I go wherever I need to go to inspire the students and keep you focused on your future.
Yeah. Yeah, and so what would you say is one of your most notable achievements in life, or your career at NASA, or even just in general?
Wow, it's good that you brought that up because one of my most notable one, I was 26 years old at NASA, and the aerospace engineer for the Army bought in this project is a weaving apparatus. It's a loom. And those of you who don't know what a loom is, just Google it, weaving apparatus, a loom, Google search it, and they'll tell you what it is. But it actually weaves fabric, using a 90-degree weave. So with this new idea, this new weaving apparatus, they wanted me to weave curved graphite frames so they can replace metal in the fuselage of airplanes. And it was a preform. So I was like, wow, I had no idea how the loom worked or how the weaving apparatus worked, but I found one on Center. Someone had a weaving apparatus on Center. So I had to look at that and see how that worked. So basically it had using graphite, strands, and it has what you call a shuttle. You have to use the shuttle to weave in and out of the other strands. So when I modified it, I worked on it for a whole year, a little over a year to do this. And so all of my drawings were sketches. They weren't professional drawings. They weren't CAD drawings. Yeah. So the Army researcher, aerospace engineer, sketched all the drawings of the items that I had to fabricate, and I was able to do it.
Wow.
And then that project was one of the projects that I got put in a patent, a co-patent, co-inventor of that weaving apparatus. So he wanted to explain the concept to his managers. So once he was able to do that with me fabricating it and modifying it, so a full-scale weaving apparatus was built in Pennsylvania at a textile company. And man, that was one of my most awesome moments because I was only at NASA for 4 years.
Oh yeah.
At that time.
Wow. Yeah, it's pretty notable, especially to have someone at that young of an age do something so revolutionary, And were there any factors such as age that were hurdles or challenges in your career at all? Did people ever look down on you or disrespect you or not hold you as to high of a standard as some of their other peers?
Actually, I can say, I've been at NASA this July, be 36 years. It's been 36 good years. But that's one thing I can say, my managers and even my coworkers, everybody give me the utmost respect. And now being a senior technician, I have other, technicians coming to me for ideas or advice. Yeah. When they lead in a project, they'll come and ask me for the advice or a certain direction they need to go.
Yeah.
And then that makes me feel good because that means they trust me and they admire my advice or what I have to tell them.
Yeah, it's great to hear that you have such a positive relationship with your coworkers and your employer, because I know there's so many people who don't have that positive surrounding, or maybe they're just not respected for some aspect of their personality.
Yes, it's so important because as a team, we work a lot together as teams too, and you want to be able to communicate with others and get along with others at NASA, because they wouldn't stand for that. If they have someone who's causing problems, and then they may, take care of, you may suffer some consequences.
Yeah.
But communication and working together is very important. Teamwork. Yeah. Of course, teamwork makes the dream work.
Makes the dream work, yeah. Yeah. And so, if engineering is one of those topics that just never really clicked for someone, what are some things that you would suggest, or resources or ways that they could just make it more fun or more interesting, or kind of help that click in their brain?
Yeah, so if engineering is not the thing for you, and I wouldn't say engineering is not the thing for me. I'm in the mechanical engineering technology background. So the difference between mechanical engineering technology and mechanical engineering is all design. Mechanical engineering technology is hands-on, but you may have some design. You do have knowledge of CAD also, but you're mostly hands-on. But I've run into other engineers at NASA Langley wish they could have more hands-on. And it's really funny that they say that. And they're like, because they almost like envious of me because I'm doing the hands-on stuff and they doing all the design. So they want to do the hands-on stuff. So again, it's back to what you're saying. It's all about, what you feel comfortable with. Now, if engineering is not, if you're pursuing engineering and it's not working for you, and then see if you're a hands-on person. See if you like building things and constructing things. Even like if you're doing building Legos, you'd be surprised what you can do with Legos.
Yeah.
But if that's not working for you, continue to find what makes you tick. Again, what makes you tick, what works best for you. Because at the end of the day, that's what it's all about. It's all about your comfortability, what you feel comfortable doing.
And so another question is, what is the largest object that you've 3D printed or built in general?
The largest, well, although we didn't build it, the largest one was going to be for Boeing. It was going to be a 37% blended wing body, and it had almost a 40-foot wingspan.
Wow.
And
at
we had
37%.
Yeah, 37%.
Wow.
So it was going to be, and we have, and that goes to show you how big our laboratory is. We have a huge laboratory, but what we had to make it in 3 different sections. So the center body was separate than the left and right wing. The left and right wing they were going to detach. But this was back in 2001, and the reason why we didn't go through with it is because that's when the 9/11 attack happened, and Boeing was losing a lot of money. So they canceled the whole project. They just, and since they were losing that money, so they didn't come back to us to build it. So we ended up building the left wing of it. But NASA is still doing research on it. NASA Langley is still doing it. And actually the design has changed. So now you have 2 engines instead of 3 engines on the back of it. There's 2 engines, and you have 2 vertical tails on the back. Now they have made 3D models out of that too, for the blended wing body. 3D printing is really, it's really awesome, and it's really convenient. I mean, you can make these models overnight. But again, there are models that they want us to build instead of using the 3D printing. So it's all about what a researcher wants. Sometimes he may want a 3D printed model, and a lot of times they may not want a 3D printed. They may want to just make a mold and do the fiberglass and graphite layups. So it's all about what the NASA researcher wants also.
Yeah, and so one of the last questions before we'll pause the recording and let some of our viewers talk directly to you. Okay. So do fires happen often as part of the process? I know you mentioned that there's like a fire station down in Langley, and so like, just, I guess, what are some of the things that could go wrong in terms of model fabrication? Like what is an exciting day look like?
Yeah, actually we don't have many fires. I mean, if you have fire, it's nothing have to do with our models or projects, but usually like the building you're in. Now we did have in one building, someone had spilled some acid in one of the buildings, and then smoke started burning. I mean, it started burning through the floors and stuff. And so the fire department had to be there. But other than the projects, no. But one thing, back to the models, now we have a good track record of making accurate models. So the one key thing about our models that we build, they have tight tolerances. Like say for instance on the smaller models, you can't be off no more than 15 thousandths of an inch. So these are precision models, and they're dynamically scaled, and that means they have to fly like the real thing. So when they scale a full-size airplane down to a model size, it has to be accurate. Everything has to be proportional.
Right.
So you can't take that lightly also, because it has to be built correct. And so we have quality assurance that check it and make sure we build these models correctly. But one thing we ran into, though, with the models, one model, we were overweight, about 400 grams. And so we had aluminum bulkheads supporting the skin, so we took a drill and drilled through the aluminum to release some of the weight.
Yeah.
So that was only one other incident, with building these models, so we were a little overweight. They'd rather for you to be underweight, because then they can distribute weight where they need it. Right. But when you're overweight, and then that's going to cause a problem, because when they test it, they won't get accurate data. Right.
Yeah. And it is amazing how, things scale so that you said 1/1500ths of an inch or so, scaling that up to full size, that might give you a little bit more, a little bit more leeway, but still not much.
Right, because that's a good point. So the bigger the model, the more you have to work with, the bigger your tolerance. The smaller the model, the smaller the tolerance. You don't have to much.
Yeah. All right, so that is going to do it for today's session of professional previews. So thank you, Sam, for joining and everyone else here. And we'll be ending the recording soon, but feel free to stay on if you wanted to talk to Sam directly. You'll be able to unmute yourselves as well as turn on your cameras. And then otherwise, feel free to join us next month, actually March 3rd. So no professional previews in February. And March 3rd, we'll have science communicators Dr. Adrian Smith and Michelle Jewell joining us. And then feel free to stop by the museum this weekend for Astronomy Days. So that's a big event that's happening here. It's both Saturday and Sunday, all day long. I'll be here, and I don't know, Sam's in town. He might hang around. But we'll have lots of fun things, and everything will be astronomy themed. All right, so thanks for joining.
Thank you.